Okay, let's get it started. Hello, everyone. Welcome to the topic Vehicle Data Model. Myself, I'm Chaitanya Podalkuru from In-Vehicle Network Architecture Group at Ford. I'm here with Daniel Alvarez from BMW. Before Ford, I have an extensive experience working at different suppliers and OEMs in the automotive domain itself. So, Daniel, how about you?
Yeah, hello everyone. My name is Daniel Alvarez, working for BMW Group, as it was said. I'm focusing on semantic data modeling mostly and how to upgrade the VSS data model that we have been working for about a decade already and looking into ways of adopting existing standards and embracing tools that are outside COVESA. And this is basically the contribution we are trying to position. And we are also open for your input and suggestions.
Thanks, Daniel. So we tried our best to give a complete overview of VDM and its relation with VSS and how you can develop your VSpec in VDM in two sessions. You can think of it like an first session would be introduction, mostly like a theory, and second section would be like a hands-on, which is practicals. Towards the end, you'll end up having an exam. Just kidding. So just pay attention. So in the first session, we'll talk about what is VDM and the most burning question, like how it is related to VSS and what are all the foundational concepts, like what modeling approach it is based on and the foundational standards and a roadmap going on. And in the second session, we'll talk about an example of how you can define a specification in VDM and how you can use it, what are all the different open source ecosystems that's available and going forward. Okay, I'll try my best to cover it in 25 minutes. If not, we can have a break and then we can continue the discussion after the session. Okay, what is VDM? So it stands as like a vehicle domain data model or simply vehicle data model, however you want to call it. So it is defined to provide a systematic approach to model different areas, not only related to in-vehicle data or related to vehicle, but also different areas around the vehicle. So when I say different areas, it could be like a person data or cloud data or infrastructure or mobility or different aspects associated with the vehicle. The term domain is overly used in automotive. So we call automotive as a domain. We call subdomains also domain. There are different things. So I'll represent it as areas from different point of views. So the scope, like I said, the scope is not limited to just in-vehicle data. When I say in-vehicle data, it's not like a vehicle properties or signal or sensor data. It's mostly or everything that's related to vehicle. Now, with VDM, you can model different domains which are interconnected with each other and establish relationships with them. The scope is not limited to just the vehicles. You can define as many areas that you are interested, but we don't recommend modeling everything in VDM, like pay as you go, define as you need. The ultimate goal that we are trying to achieve, if there is an organization or member organization who wants to model their area from their point of view and they have a subject matter experts, we want to reduce the effort on adaptation for them and also spend more time in defining the domain and then be flexible in defining these areas. Of course, the member organizations can obviously steer the direction, the scope of the VDM here. So as we need, please join us in the weekly sessions or all the discussions to see if it fits your needs. How VDM is related to VSS. So if you're new to COVESA and not sure of VSS, VSS stands for Vehicle Signal Specification, which is kind of like a controlled vocabulary where different member organizations agreed upon how the vehicle properties or sensor data needs to be defined, everything related to vehicle, and by following the modeling guides defined in the VSS project. So in VSS, we have a modeling guide, how to define those things, and there are tools associated with it. And you can define everything that's related to in-vehicle data. So when it comes to the VDM, as I mentioned, it's not just related to in-vehicle data. It can have multiple areas or domains which are interconnected with each other. VSS or in-vehicle generated data can be treated as a subdomain in the VDM. So if you already have established your toolings or anything around VSS, you can always, there is a command on the VSS tools where you can export the VSS VSpecs into STM format and seamlessly integrate with the vehicle data model. So with respect to the operational modes, this is pretty typical and common wherever you go. So we all wanted to have that abstract model where we want to model it once and use everywhere. So VDM follows the same standard as like a VSS. We want to model it once, so-called specification, and which has, by following the specification guidelines, you can define the specification files, and there will be a tool supported to generate all different artifacts that can be used in your physical layer. When we say the physical layer, it's mostly like a different artifacts. It could be a database schema or JSON schema or CSV or API specification, or even directly the C and H or the header files that can go directly to the ECU. So it follows the same standard. There is nothing different with respect to the way the operation is working here. How VDM is different from VSS. So why can't we achieve what we are trying to do with the respect by following the VSS itself? So there could be many differences as such, but here are the high level things that we wanted to highlight. So when it comes to the structure on the left-hand side of the structure, so VSS is mostly like a one-dimensional, and it has a point of view from the vehicle. It starts with the vehicle, and then the cabin, or like, subdomains, and then the door, all this kind of like a hierarchical model. So it's mostly like a tree or one-dimensional aspect. And mostly the modeling perspective is from the point of vehicle view. When it comes to defining a person data or any kind of like a trailer data, then you may need to curate your data from the vehicle point of view. And the core modeling language of VSS is YAML based, and obviously it supports human readable and machine readable. That's great, but the schema is based on the custom construct that we built in the VSS project. Like I mentioned, the scope is very limited in VSS to define. It works great for representing sensor and actuator data. It's mostly limited to the vehicle aspects. Whereas VDM is concerned, it's more of like it's based on a language that represents a graph. So you can have your data model or domain model can be started from any point of view. So I can start from person, I can start from cloud, I can start. So depending on your use case, you can start. You're not bound by following one dimensional aspect. It's more of like you can start anywhere and you can establish relationships. This is the main difference that we are trying to do here, so that if you have a domain area or domain subject matter experts from different domain areas, which are totally out of automotive or within automotive, and who are not used to or not related to don't deal with the in-vehicle data, then you can start modeling your domain in this format, and then you can establish interconnections between them. So that's the main thing. And the core modeling language is well-established GraphQL SDL. So some of you might have already heard about GraphQL. So there are two concepts about it. It's more of like an API or schema definition language and the API aspects of it. So we're not dealing with the runtime application of what GraphQL is teaching us. It's mostly like we are leveraging the schema definition language so that we don't have to reinvent the wheel and leverage existing ecosystem, existing tool chain that are already out there, and different communities outside the automotive are using it. And the scope, yes, it's not just limited to the vehicle data. It's more like any subdomain or any domain which can interface or interact with the vehicle data. Now, you can have a vehicle signal specification defined in VSS and rest of the domain defined in VDM, and then a relationship can be established between them, or you can define everything in VDM as well. So this is like a fundamental difference with respect to operation and how the files are organized and what are the things associated with VSS, starting from VSS, from the VSS point of view. So on the right-hand side, when I say right hand, it's my right hand, okay? So sorry, on the left-hand side, we have the VSS specs, which are like a vehicle signal specifications, which are like a sensor and actuator definitions, can be units or data types, range, resolution, all the aspects around the vehicle in-vehicle data, which are commonly agreed upon by different member organizations, and then build together VSS specification files, which are stored in GitHub as a VSS directory. So that's the one most of the SMEs will be actively working on. But how they define by following the modeling guide that's defined in the VSS project. So far, if you see from the high level, so VSS provides two different sets of artifacts. One mostly like an modeling approach, how to model your vehicle specification and the real artifacts by following the modeling guidance. And obviously, there are tools associated with it to ensure the consistency of the data by following the modeling guidelines and export, validate, and convert it into different file formats based on the need. So VDM also follows the similar approach, but with a slight change of leveraging the existing resources here. Instead of defining our own custom modeling guideline, we will use the existing standard and existing tools and build a simplified semantic data modeling approach on top of it so that we can leverage all the open source standards in defining our data model. So we'll go more details about S2DM, why we have to do it, why can't we just directly use existing standards into it. So we'll go more details as we go further. Now, that's at the high level what VDM is. We can go more details into S2DM. Like I said, S2DM is like a simplified semantic data modeling approach. It's not a data definition language. It's not a data schema language. It's more of like an approach or a design how you can leverage the existing standards and curate them to our own needs and put some constraints around it and build some tools around it that's needed for our domain. So, and in addition to this, most of the typical problem that we see as the schema evolves, because we are working to define these standardized schemas by collaboration. So things may make sense today, may not make sense tomorrow. So we might need to end up changing the schema definition language. For example, if I say vehicle speed, yes, if it is like a UINT 8 today, maybe we might change it to UINT 16 down the line. So the S2DM is kind of like a modeling approach, which can make sure that unique resource identifier is associated with those schema changes and then provide better traceability while supporting the current systems and also future. So why we had to do with S2DM, basically, there are three key main aspects we wanted to highlight. So the first one would be the data-centric adoption. So all the organizations, if you think of like an OEMs or bigger organizations, obviously have their legacy systems or evolved systems, which could be existing from decades, or they want to translate or adapt themselves or curate themselves to build a data-centric systems. So there is a concept which is kind of like for the data-centric approach as taught by like a semantic arts. So any domain or a data set you want to define, so it goes from top to, can you see? Yep, it goes from top to bottom. So T box, C box, and A box. T box stands for like a terminology concept. So basically you define something called terminology like a car, a building, or a cloud service, or infrastructure. This is kind of like a terminology that we have to have agreement on how we define it and how we use it anywhere. And each of this terminology can be spread into have like a subdomains, like a categories of terminologies, which are like, okay, so if I speak of car, then you have like a cabin or powertrain or transmission. So these categories evolve from the or relate to the terminology. And then in the bottom layer, you have the assertions or instances. So now those could be the variables or properties or the instances of definitions or interfaces, something like this. So ideal approach, if you want to go with a data-centric adoption, then we ideally should follow top to down. So most of the organizations, if they ideally start with the top to down, but over the period, in order to have better, faster, cheaper, any change mostly happen at the bottom layer and not often cascade to the top layer. So that's where the reality goes like, okay, so we start with top to bottom. Oh, sorry. We start with top to bottom, but in reality, we let the developers or database managers or all the people who are playing with the day-to-day real life data schemas, let them change or update their databases or the schemas or data models as they need. And eventually you'll end up having these kind of triangles within the organization. Forget about community-wide, it's more of like within the organization, we'll have like a conflicting definitions of terminology, what we call an ECU, what we call an the vehicle and all these kind of things. So that's where the current problem where all the organizations are struggling towards transforming themselves to be like a data-centric companies. Now, what COVESA is trying to do is to get into like a middle ground approach here. So bridging establishing a gap between the top to bottom and bottom to top. And before that, I want to highlight like, okay, so if you pick one of these chances, one of this side, then you will have a risk or problem associated with it. For example, if you go top to bottom, and obviously your complexity and adoption effort will be high because every time there is a change, you need to spend more time. And the development too. So the development activities will be slow because there will be multiple agreements that you need to establish between these terminologies and the relations. And obviously you'll have like a long-term benefit because you have a robust data model established within a domain. But if you pick like an application centric, you'll get the outcome faster and you'll remove the blockers between different workflows. Eventually, you will have, it's like a short-term benefit for you. So the COVESA VSS is COVESA VSS try to resolve this by establishing a missing bridge, having like a middle out approach, which is more of like a pragmatic approach. Let's all agree upon the concepts and then we can adapt. So we standardize how we define these terms, how we define these subcategories, how we define these attributes to it within a domain. So another problem that we have when we try to do is like for any subject matter experts or the people from different domains, if they want to collaborate and actively build a data model around it, obviously you'll see these are all the common categories that we considered to compare against what can support to get different domain subject matter experts to work on this. So I won't go into details of everything, but explicitly, so VSpec was defined with a greater requirements at the time when it was defined, but it may not be expressive enough to support all the needs to establish interconnected domains. So some of the things that I wanted to highlight is community and tools. When it comes to the adoption, so if every company onboarding with the community practice, and if they had to spend more time in adoption or training their own people or spend more time on building the tools and resources, then it's going to be a little hard if we have more investment going in. So we want to spend more time on aligning ourselves, how we define our data schema rather than spending like all the infrastructure around it, adoption, and then the training the people and all the stuff. And the second one is like a cross-domain references. Like I mentioned in VDM, first slide, it's most of like if I want to establish a relationship between different domains. So because VSS is so centric towards from the vehicle point of view, you cannot always see the data through the vehicle point of view. Now we are already crossed that barrier of, okay, so we need to look at the automotive domain. Vehicle is just an entity alongside with other entities too, which could be person or trailer data or all this kind of things. So that's where VSpec is lacking a little expressiveness and in defining the different domains and connect them. So if you go one level deep inside it, the fundamental blocks of how the VSpec is formed and what we are trying to do here is, yes, VSpec supports in-vehicle data. It's based on YAML, which is machine readable and human readable. It's great. And some of our companies are already, even in my experience, we built our own custom data model based on the YAML. But typically the problem arises when it comes to the adoption. Like I mentioned, it's mostly like we need, as we are working towards as a community-driven approach or the initiatives, we don't need everyone to build their own tools and we don't need everyone to build their own expertise and so we want more people just directly jump on defining the specification and agree upon the standards. So anytime there is a change or approach or the schema, then it requires a custom tooling too. So what we are trying to do here is, okay, so let's work on top of the established language, not only within the automotive, outside of the automotive, so that we don't have to spend more time on adoption, we spend more time on agreeing upon the data scheme. Okay, so we'll go over like a foundational aspects of what the S2DM is based on. Like I mentioned, S2DM is just an approach, how we can leverage an open source standards. So we picked GraphQL SDL, schema definition language. So GraphQL has a rich ecosystem of tools and it's widely used, and even you don't have to specially train your LLMs or Copilot how to work with GraphQL. It's already aware the schema definitions, and there are rich open source tools that are available, how to translate or transfer the GraphQL content into a different file formats. And if there are any missing things, we already have in extensions like SCOS or RDF extensions from Semantic Web. So it's to give you a simple idea how GraphQL would look like. So we kind of created a small snippets of content so that we can walk you through, so that you get at least a cleaner idea of how the GraphQL would look like if we want to define all the data models by leveraging the GraphQL STL here. So like I mentioned, GraphQL is like a strongly typed language. So there are different things, different languages that are there for modeling language, schema definition language that are available. So we evaluated subject-wise, but not like we don't have like a proven record of what works and what not. So we have like we reviewed all the different things, and then we came up like, okay, so this would be an ideal way to define our data models by leveraging GraphQL schema definition language, and then build on top of it. So we're not here like, so we're not planning to or support, you can, but we are not planning to support any kind of like a runtime applications of GraphQL. Basically, as we mentioned, we're only leveraging the schema definition language from it. So given an object, so it's always like a type language. So as you see here, we have a vehicle. Vehicle has some different fields, and fields are typed and etc. associated with this object. So we'll go one level details. Yes. So here I can define a vehicle object which has a fields, and GraphQL by default supports like a type modifiers and cross references to. It's more of like if you want to define like a nested structures or the list. So everything are supported by default. So we can leverage so that we don't have to build most of the tools that are associated with the GraphQL by default understand what we are defining here. So I'll go over some of the examples. This is like an example of how you can establish a relationship with other object with an enumerations. So I have a vehicle is of type brand, vehicle brand is an enumeration. So which you can say like, this is how you can establish a relationship with or establish a cross references to other definitions. So usually we don't recommend extending types, but you can always by default extend type. Like here, the type is of door, and is open is a field that's by default. And then I can extend the door type with an instance tag on top of it. When you compile these files, you will get a type door. So if you have your own in-house requirements that you want to extend these definitions and then build a custom artifacts, you can still do that by just simply using the existing ones. You don't have to reinvent the wheel here. This is another example of how you can define or leverage instant tags. And this is another example how you can define a unit. So we can have like a control set of compatible units that we can all agree upon, and then assign here the vehicle length is of type float, and which is of unit meter here. So these are all different STDM custom directives. It's more of like some of the directives that we can build on top of it. Like we can apply the constraints to the value by defining the range and cardinality. And we can even, so if you have custom that we all agree upon, okay, so I'm defining my vehicle signal specification in VSpec. And when you translate it or convert it into STDM format, so we can add a custom tags on top of it so that we are all clear. This is the in-vehicle data that's defined by using VSpec, but it's taken into the VDM ecosystem here. I will let Dan take over from here on RDF and SCOS.
Yeah, thank you. It is already 30 minutes past. Should we make the break to just stick to the schedule, and then people can have coffee break and we come back, we take some minutes to explain the rest of the session?
Absolutely.
Okay, so then let's do that. How long is the break, do you know?
Break is supposed to be 25 minutes. 10:30 to 10:50.
We can take half an hour, and then we can continue.
Okay, so then let's meet again in half an hour, and we continue from here. Does that make sense?
Or do we continue and then take the break?
Is there want to continue, or do you want to take the break?
Continue the first session. Okay, Dan, please continue. Any other objections? Okay, we'll finish off the first session introduction, and then we can have a break. Thank you. Continue,
Okay.
Dan.
Yes, thank you. So basically, when it comes to extending the model that is meant with the vehicle data model with VDM, as it was explained, the core basically is founded on the GraphQL schema definition language, but we can extend it by enabling future-proof identifiers and then just working with semantic web standards. For those who are not familiar with semantic web, basically the main standard in the semantic web, it's called the Resource Description Framework, or RDF for short. And basically RDF is a data graph that resembles a data format, a data model that resembles a graph. And it basically matches the way we normally express our knowledge about a domain. And this is done in the same sense as we construct sentences with subject, predicate, and objects. And this construct it's called a triple. And for example, you can have Daniel works at BMW. This is a triple. And then an RDF data set, it's also called a data graph. It's nothing more than a collection of such triples. But in practice, what this means is that this is also a text file that follows a certain syntax. In the example you see at the bottom right, it's a format that is called Turtle. RDF has multiple serialization formats, but in this one, basically you have the triples. Subjects are always given on the left, as you see, Daniel or BMW, and then the second element is always the predicate, and the last element is the object. And then the triples are separated by colons, semicolons, or by semicolons or dots in order to make the distinction of different triples. So in this case, you have the same graph that you see on the left is represented with text saying Daniel is a person, Daniel works at BMW, and also BMW is a brand, is a company, and is an OEM. Next slide, please. And okay, so once you have the data graph, it is possible to construct semantic models out of it to abstract a certain domain. And this is done by using vocabularies that are compatible with this technology in order to organize the principles that are classifying the information of the domain. For example, if I build on the same Daniel works at BMW example, this triple, these entities can be basically also referred or they can point to the aspects or classes to which they belong. So in this case, Daniel is of type person, and then BMW is of type OEM. And when you are using this technology stack, you don't even need to say that BMW is a company. So you can also enable aspects like features like reasoning. For example, if you have this in place, basically you will be able to infer that BMW is also a company, or that Daniel is an employee, even though you didn't mention that explicitly in your data. So it's possible to construct also these kind of models, and they are often referred as ontologies or taxonomies if you just work with classifications. Next slide, please. Yes, so this is an example how this looks in practice, targeting one of the vocabularies that is compatible with RDF. There are plenty of them, so we are just focusing these examples on the SCOS. SCOS stands for Simplified Knowledge Organization Systems. And this is basically a set of terms that let you express aspects about the concepts. So concepts like an employee, you can classify this employee in different hierarchies. You can provide alternative labels in the form of synonyms. You can have the same concept specified in multiple languages. And all of this is mostly important for data cataloging purposes. So if you think of data, there are two main work streams. One is searching for the data. This is the purpose of a data catalog, so that people that work with the data can actually find the concepts of interest. And once they find it, once the concept of interest is found, then the other work stream would be to search in the data, doing like data analysis or also machine learning on top, or any kind of data usage. But this is basically improving the way you have the experience of searching, in the same way you have an online shop where you see several categories. For example, in an online shop, you can reduce the scope of the search, and this is the purpose of SCOS. And then SCOS, on the left side, you have the turtle serialization of the example for employee, and there you have multiple labels in different languages, like empleado in Spanish is the same as employee in English. And this is basically considered as an extension because not everyone in the alliance will have the same use case, right? So this is driven by use case. You can do some interesting things like grouping concepts arbitrarily. You can, as I said, provide alternative labels or multiple classifications, among other things that we are not covering at the moment. Next, please. Yeah, and once you have this, since this is a standard, an open standard, you can also use existing tools. One of them is being able to visualize. Imagine you have a data catalog that can serve your data concepts in multiple languages. So in the end, you have these hierarchies that can be constructed from different perspectives. But the information remains the same, right? So it's seen as a complement to specifying the data structures in the language that has been explained at the beginning. Next slide, please. Yeah, so I hand it over to you, and then we continue.
Okay, so STDM approach, basically why we needed STDM and how it is different from rather than just using the open existing standard by directly. So this is like a fundamental layout, how we are defining it. On the front end, you will see like it's kind of like a three groups. A is kind of like what you define an object or schema on top of it. And section B is like it's kind of like a backend of how the schema will translate the objects and maintained either by assigning a unique resource identifiers and register the specification changes and all these things and respective associated tooling around it. And C would be like an extension if we need to extend this with multiple classifications and extend it to define synonyms and extract an ontology out of it, we can leverage extensions out of it. So if I correlate this with a typical example, so typically the subject matter experts work in this area where they define the objects and fields for a domain and how they are related. It's all the work here. Everything on the B is in the backend, that's STDM tooling supports, where it translates the schema definition into by assigning a URI, unique resource identifier, and then there is an spec registry that maintains a traceability of how the specification has evolved over the time and any variants associated with it. And obviously we can leverage some of the capabilities of by reading or updating if we have a database schemas or anything that's associated with it. So speaking of an RDF based extension here, so the physical layer you can have so let's take an example of window. So you can see it can be modeled from two directions. So there is a domain which can say like a physical membership. So vehicle has a cabin has a door has a window. It's more of like a physical location of a window. When it comes to the different way of looking at the window, so I have a vehicle, so there is a movable object. It can move unidirectional, that's window here. So you can define a specific data sets and you can correlate with the different ways of looking at the data here. Roadmap, we can discuss towards the end too, but here is the high level where we stand today and where we are leading towards. Of course, this can be adapted based on the interest and needs from different organizations here. So STDM evolves as its own as a foundational concept or approach and tooling associated with it. VDM is an application on top of STDM. So VDM is the where the VDM is hosted as an alliance activity. So if you have a different domain, that can be an application on top of STDM. So the active work is like a VSpec. If you have the specification that's defined in VSS format, so we are working on round trip VSpec to GraphQL STL and then GraphQL STL to VSpec. But currently we are targeting to have like, let's define the VSpec in VSS by following VSS guidelines and translate it to the STL. And enable the federated data modeling. That's another topic that team is actively collaborating on. So another thing that I want to explicitly mention, it's not just BMW or Ford involved in this. There are other organizations like Renaissance, Geotab, and other folks. Apologies if I miss anyone, but we all get together every week and to curate and transform the project and make some decisions over there. Please feel free to join there. And so we're planning to have like an STDM officially released as a Python package in PyPy soon. Once we have all the required commands and translation layer implemented. And we also want to integrate LLMs to this so that people don't have to separately build on top of it, so they can leverage some of those features. So speaking of vehicle domain or vehicle data model, so this is where we want to more collaboration in agreeing upon defining different domains and then generate any artifacts that different teams need. So we want to define the scope, which is actively working on, and then integrate VSS into VDM, and the subdomains can be based on needs, like a person or trailer or different domains associated with it based on need. This looks at the high level with the information so far we are aware of, but feel free to join, provide feedback, whatnot. Okay. With that, we will wrap the first session. It's 10:40. How about we gather at 11:10? Sounds good? Yep. Thank you, everyone. Thanks, Daniel.
Yeah, see you in a bit.
Yep.
Thank you as well.
Is
Back at 11:10.
11:10. Yep. How do I stop recording? Or it is completely off already?
Was Paul recording or was you?
I don't know. Paul might have started.
Maybe in the Zoom, but be the host.
Wow. Yep.
Can you confirm you see the slide?
Yes.
Okay. Thank you once again for those who are coming to the second slot. I guess you were also part of the introduction, or at least most of you. We will provide more detailed information about the current work and practical examples on how we can basically realize this modeling approach, and also how this can be realized in the context of COVESA, and how we can combine, for example, multiple domains. As I said, my name is Daniel Alvarez. Together with Chaitanya Podalkuru from Ford, we are leading this working group that is based on this upgrade experience when it comes to semantic data modeling. So the second session is planned to contain the following items. I will give a brief overview about the artifacts, the repositories that are public. Then we will basically walk you through the modeling experience when it comes to start from scratch a new domain, and also to import an existing specification written in the current VSpec. And once this is done, basically we will play around with some of the tools that are available in order for you to have an idea of the functions, the scope, and also to bring some of the let's say some content to initiate a discussion at the end in order to gather your suggestions, comments, or even addressing your questions if you might have. At the end, we will touch, if time allows, some aspects that are basically in a conceptual phase still, and some of the possibilities we can do with this approach, as well as the roadmap, revisiting the roadmap, and then just open the session for questions. Good. So let's just get started. As it was explained in the first session, there are some artifacts associated with this initiative. And to be more specific, we talk about a modeling approach, which is called simplified semantic data modeling. It is simplified for a reason. We are not trying to reinvent existing standards like those of the semantic web, but rather embracing them in order to adopt certain best practices when it comes to modeling. So one artifact is basically the modeling approach, which consists of a certain modeling guideline that is explaining you instructions on how you can formalize your domain with this approach, as well as some tools that are letting you do some governance purposes, like governance processes like searching over the catalog, exporting in different formats, and some other functions that I will cover within the session. Feel free to just visit the repositories. Basically, they look like this. So when it comes to the modeling approach, you will have this S2DM repository in COVESA, and it also has a documentation page which is being reworked right now. So if you don't find the information you are looking for, or if you think that some pieces that require attention, feel free to just create an issue in the repository so that we can prioritize this. Just bear in mind that we are working on this, and some parts might not be comprehensive still. The same applies for the VDM. This is basically the application of the modeling approach, which has its own space within COVESA. As you see, is a public repository. And in the main branch, it is basically empty for a reason, because we are looking for first adoption, and then also for proper use cases that COVESA can focus on in terms of standardization initiatives, and also subdomains in which subject matter experts from different companies can contribute and can also commit to maintain it, right? So it looks a bit empty in the main branch, but we are populating some other branches with examples, and you can visit them to have an idea, and I will try to cover some of the items today, also referring to one of them. Good, so let's go back to the presentation mode. Good, so I will try to do this a little bit dynamic, and in order for you to have an idea how this modeling works. Can you please ask the audience there about the familiarity with the GraphQL language, just for me to know how deep or how much should I simplify the process?
You're already familiar with GraphQL? Very less. I'd say 10%.
Okay, good. So, okay, so this is the example we will go through today. Basically, we selected a charging session as a subdomain we want to model, and it contains at least 3 subdomains or 3 domains that require cross references here. A charging session requires a vehicle, a charging station with the charge points, and also a person, right? So at least we have these 3 different domains. And there are simple steps you can follow. This is not deterministic, let's say, methodology of modeling. There are different ways of working, but I think this is a simplified approach on how you can leverage this. First point is defining the scope. In the context of this example, we have charging session. Then we need to identify what other entities of interest are appearing in this subdomain. In the example, we have these three that I have mentioned. And for each of them, we need to also list all the relevant properties that we want to report, that we want to formalize. And we do that for each of the entities. Then once this is identified, you need to start typing down this language, which is basically mapping your ideas to the proper syntax. If you have an entity of interest, this becomes an object type. If you have a property of this entity, this becomes a field of this particular object type. I will show you in a second. Once this is done, you can adopt some of the, let's say, constraints that the modeling approach is offering you, like specifying a range, saying, okay, I have this property and I know upfront that it can take a value from a certain minimum to a particular maximum. So you can do that annotation if you need. And then you can basically simply use that in order to achieve your goals. It might be that you want to drive a database, then you need to export into a certain schema language other than GraphQL. And that is the purpose for the tools, right? Just a remark here, since this is a type language, the modularity is essential. So you need to focus on granular objects that are controllable such that you can basically reuse them in a bigger scope if you want. Good. So when it comes to the person, let's start by that domain. You have some properties for a person, let's say the ID, name, date of birth, the address, the gender, an email, and these kind of things. So let me just jump to the code. As you see here, I have an empty repository. I hope it's visible for you. So what you do is basically you create a directory here, let's call it spec, and then you can create, let's say, a subdomain folder, which is called a person. And then you want to create in this person, person.graphql, right? So this is the model I want to have. As you can see, this is recognized by extensions in code editors. So that gives you directly highlighting linting capabilities, which is quite handy for this. And then when we model basically the person, we need to just translate what we had before. So we have a type person, and then this person has an identification, which is an ID. It has a name. Yes, it has a name, but I want the name to be like something that is not a simple string, but let's say I want to have a person name that contains first name as a string and last name a string, for example. Then we can have what else we can have? We can have a gender, and the gender, we want to have the gender as a control set of items. And then in this case, it's an enumeration that says this is a gender. And yeah, it can be like male, female, other, just for examples purposes, we will keep it in that way. Another interesting element is, let's say I create a home address, but instead of having a home address, I have as a string, I have a concept of an address. And then I want to create, let's say, another file that is called address.graphql. And then this address can have the street, a city, a state, a postal code, and so on. Yeah, so this is kind of the person we want to model.
Model it.
Yeah, so that's pretty much for the person, I would say. Like, so let's just keep it like that, and let's move back to the example. Where were we located?
39.
Exactly. So yeah. So in the end, we end up with something like this. Yeah. So we have a type, which is the main type of interest, the person, and then from there you continue to just grow by need. So you pay as you go, right? So you don't basically create the model for everything you think of, but just for the data that is relevant, and also for the data that you are able to provide, right? So this is what we did, more or less. This is the person. Then we have another element, which is the charging station. And then for the charging station, we need to, for example, provide whether this is a parking lot, is a garage, does it have one or multiple charging points? Maybe there is an operator that is driving this, and it also has an identifier at the location, just to mention a few concepts that might be appearing here. So we can do the same as before. We can create charging station, sorry. And then the charging station has also a file, let's say charging station.graphql. And then we have a type charging station. And on this charging station, let me see what we had there. Yeah, exactly. So we had also an ID, and then we had a location. But location, I don't want to be like the address, because I want to also have maybe coordinates that were not given in the address. So instead of doing that, I will say like I will provide a location as a type, and then in here you can specify, let's say, a location. And then this location basically can be something like this, where you have an address that we specified before, and then we have a geographic coordinates, and then we need geographic coordinates, which can be a float, for example. So as you see, this basically is about modeling standalone concepts that can be reused, right? So we are reusing the address, we are reusing the location, and then we go back to the charging station, then we are pointing to this location over here. Good. So another concept that is important here would be, let's say, the charge points. And then I want to have a collection of charging points, and then I want to specify what a charge point is. So let's say the charge point I have is, so it has some ID. Of course, this must have an ID, and then it will have some connectors, and then this is a type, let's say connector, and then connector can be an enum that says this is the type of connector I can have, right? And then you continue to do the same for other fields that are there, but for time purposes, I will just keep it flowing, and then just continue with the example, and I will show you how it looks like at the end. Another aspect that was important is like the parking type can be like, and then this is parking type, and we can say this is an enum of a parking type, and then this is in the street and garage, off-street, other, and so on and so forth. I hope you get the main idea. So if we move back to this example, basically, we basically model the charging station and also connections to other aspects. So you have, as you saw, location is a type in its own, and then it is connecting to the address that we modeled before, and it is also connecting to geographic coordinates, latitude and longitude. So all these types are reusable. So they are not belonging only to the charging station. They can be reused. That is very good for maintenance purposes. And then once we have this in place, we can move to the next area. And this area basically is the vehicle, if you recall the initial figure of the example. And instead of modeling the vehicle from scratch, I decided to go and do the migration from the current VSS, which is covering the in-vehicle data mostly. And for that, basically, we can reuse these specifications that are based on this VSpec language. And how we do that is basically we run the exporter that is available in the VSS tools. And then you create these kind of structures that are compatible with this modeling approach. And then you simply use those files in your project that is following these guidelines, right? You may wonder, like, once you are there, whether you can come back, because you might have the need to run tools today that are based on the VSpec still. And it is possible. So we have done a mapper translation that is exporting the GraphQL files back to the VSpec syntax. But it is important to note that we are basically converting between two different languages in terms of expressivity. And when you have different level of expressiveness, not every single feature will be mappable, right? So for everything that is today available in VSS, you can construct GraphQL, and you can move back for all those features. But if you start like doing cross-references, for example, cross-references are not supported in the VSpec, or other features that are not supported, like intersections, units, unions, and this kind of stuff that is coming out of the box from this language, these are not mappable unless there is an upgrade in the language of VSpec, but at the moment, it is not the case. So the backward compatibility means backward for all the features that exist. Yeah. And this is basically looking like this. Let me see where it is. I think this is a project I had. Good. So what you see now is the VSS project, the COVESA VSS project, the public specification, so to say, where you have all the VSpec files here given, right? And then what I did here is I ran the tools from VSS tools. If you ask the VSpec for help, VSpec export, and then help, you should be able to see, hopefully. Yeah. So you see here there is an exporter that is called S2DM, and when we run this exporter, basically we can create an export here. Where is it? How is it called? Example export, like this, and it creates these kind of structures. So you have like vehicle type, and all of this is coming from VSS. So every single element is coming from VSS. You have instances, you have, for now, units also included. We have a strategy for handling better the units, but just for you to have an idea that this is basically imported fully from VSS. Good. If I go back to our example, so what we are doing is we are taking the tree of VSS. I found this image a bit funny because I was looking for a vehicle with a tree, and then I came across with this image. I thought it was like funny to just take it. The idea is to just move from the tree to the graph, and then in the graph you can basically connect to the other domains that we specified before, right? In this case, the tree in this new format is. You said something? Okay. So once you.
Dan, just hold on. There is a question.
Yeah,
Yes. Go ahead, please.
I don't know if Dan can hear me, but the YAML files in VSpec, don't have that richness that the VDM model have. Right?
Yes.
Which also means that to go from VSS to VDM, you have to supply additional information about what things to group together. For example, these three things should be part of the, I don't remember the example we did, but should be part of the vehicle or person, and these fields go together. So is that coming from another specification that, the tool is loading from somewhere else? Or is, because there can be multiple mappings as well in theory, right? So is there the one mapping that's somehow specified as part of this tooling?
No.
Or where's that sort of gap being filled?
That should be modeled directly in VDM, basically from VSS, because we already have an agreed upon specification in vehicle specification data in VSS. So we are supporting only a translation of converting VSS to getting in here. So rest of the domains of what we are suggesting is to just directly define everything in VDM and establish it. The reason we went through this example, because we are not just saying this VDM as a concept, we already proved out by establishing a simple example. So any other domain or types that are not part of the VSS spec has to be modeled in VDM.
Okay.
So if you have anything in place that's
Yeah.
already there, and if you want to contribute and you need help of converting that from your domain to here, we can discuss and then work it out. Or you can build by yourself and then you can translate it to VDM and start directly pushing to the VDM.
Okay.
Go ahead.
So I apologize, I was not in the earlier business section with the description of it, but the VDM, as you just stated, is really more elaborate information than VSS, right?
Right.
So there's more details in there. Am I correct in understanding then that while VSS is of course the vehicle signaling, this is more of a vehicle scenario? So we've got a charging scenario. We could imagine other scenarios in which, in this case, it's not just the vehicle, it's the charging station, it's the person, etc.
It's more of like like we said, the scope is endless here. So you can define or a model as a standalone, and then you can define the use cases. However, we want to establish relations. We can look at, that's the advantage of VDM. It's not like it's not teaching you to get a hierarchical model or bound by one set of. So you can look at it from different angles. Like if you're looking at from the use cases. So yes, so let's define the models and build a use case which connects between them. So we can curate or define the VDMs as ever we want based on the needs. So VDM has a bigger scope rather than looking at from the in-vehicle specification data only. So you can define multiple domains and connect them between them as a data model, and also define use cases and features. And eventually, at the end of the day, we want to define it one place and then generate different artifacts that we all have established in our own organization. So that's where we are picking the GraphQL and the VDM as a foundational source to connect all these pieces together. Anything to add? Yeah. Go ahead.
Can I continue?
One more.
Ask you about it. I wanted to understand why GraphQL not Protobuf was used. Like, what is the advantages of using?
So there are two ways of looking at it. Dan, please just add if I miss anything. So protobufs are kind of like a technology specified, and it's most of the times we look at it from the interface point of view. So all of us, we look at like a signals and services because those are the ones acting as a contract between the vehicle to the outside or within the vehicle. So when it comes to that, yes, protobuf might serve some of the purposes there when you are looking at the bigger picture of defining them, and then we can eventually generate protobufs out of this bigger model. Daniel, you have anything to add?
And to complement on that question, so protobuf is indeed good alternative. If you recall how this idea was introduced, is basically without thinking of the technology first, let's first like conceptualize a simplified approach of modeling. And then the selection based on some of the criteria that we listed, this mix between GraphQL and also semantic web, in our view, had more benefits than other alternatives, like going fully with RDF, or also a good contender was, as you said, protobuf together with gRPC. Those are valid alternatives, and the same idea can be implemented with that language as well. There are like some minor, let's say, differences when it comes to the features, because those two languages are not fully mappable, but it is indeed an alternative, but it could be used also as the fundamental language, because it's also well adopted, especially in automotive, whereas GraphQL goes beyond automotive. So there are some areas where they differ, but yeah, I hope I can answer your question.
Good.
May I continue?
Yes.
Okay. Thanks. So yeah, so the idea here is to just reuse existing BSS in the sense of, okay, I have the vehicle concept with all the components inside, or on all the data that is basically inside out, so in vehicle generated mostly, and we can do that in this way. And then we come to the actual domain of interest, which is the charging session. And in the charging session, you need to connect the vehicle, you need to connect a person, and also the charging station or charging points. And basically, these can look like this. Based on the concepts that we cover, you basically can point to the concept of a vehicle that was imported from BSS, the concept of a person we initially modeled, and also the concept of charging station and charging point that was also modeled here. Good. And this in the altogether looks like this. Oops. So in a similar structure I was showing to you, you have a specification, some subdomains, you have the person here, gender, other types, like you have also the option to extend the set of data types in these languages. They are called scalars, to handle certain cases like, okay, this is an email address, or this is a date time. So you have some possibilities there. Common types, like I mentioned, the location is something you can reuse in multiple places, address, geographic coordinates as well. You have the charging session, you have the charging station, and basically this is the one that is connecting the dots in here. So you have the charging session, sorry, is the one that is connecting the dots. So here you have the vehicle, you have the charging point, charging station. You can do it in a modular way in order to facilitate the maintenance of this. Good. So that is from the modeling point of view, the process. So again, subject matter expert is expected today to know the basics of this language, which is a type system. As you see, is quite easy to understand. It has a very shallow learning curve, but still you need to have a certain knowledge of the language. As the roadmap was presented in the last session, and it will be covered at the end, we have in mind also ideas for further simplifying this process with the support from language models, in order to reduce this entry barrier even more. So let's go back to the presentation. Good, so this is where we, okay. So now let me just walk you through some of the uses of the tools and also like touching what options you have outside COVESA when it comes to these languages. And for that, I will basically introduce the command line interface of S to the N. So today we have this CLI is the interface we have that is implementing some functions that come on top. Functions including, for example, validation. This means proving that the use of the syntax is correct. You have other functions for checking. This means proving that you are using the constraints of the modeling guideline in the way they are supposed to be used. You have also options for composing a schema, which means like taking multiple directories and then just constructing one schema model from multiple places in order to facilitate this federation of the modeling. You have also pointers to other libraries that do the checks between two different versions of the schema in order to detect differences and then just trigger semantic versions out of it. You have export commands in order to translate the schemas in GraphQL to another format like JSON schema. And you can do some search functions on top of that, like similarity search as well, gather statistics, and also like importing units from an existing standard. So I will just cover some of these functions in the examples, but for you to know, the steps are quite straightforward. In order to use this, basically you need to clone the repository. You move to your repository, you make sure you have this UV package manager installed, and then once it's there, you install the dependencies. And once you are there, you activate the virtual environment in order to avoid you typing every time the initial part of the command saying that you are executing something from this environment, so you can have it active. And then you can also trigger the help to see what is there, right? Because this is changing constantly as this project evolves. Some functions might be not up to date, or might be outdated when you watch this recording again. So feel free to just refer to the repository for the latest state. Good. So I can show you then some examples. If I can just go here. So I have the console open. Is it big enough for you guys to see?
Yep.
Okay, good. So as you see here, I have the virtual environment active. So in the end, I can trigger this help as you saw it. So here we have some commands, and what we can do is, for example, let's start with the validation. We can validate that the specification is correct, and you will see, for example, a valid output here, which is given. This is basically the compose schema of everything that I have modeled before. So everything is in here. What this means in the end is that the language was used properly. So what does it mean if you change instead of type, you call it types, then you save it, and you run it again. This should complain. because the language is not used properly, right? So we go back, we make sure it's valid, and then we can do that validation. So I expect that some of these functions are expected to be used in continuous integration workflows. So that means that normal user will not deal with that, but rather the team that is responsible for this will automate this in the GitHub pipelines, for instance. What you can also do is, let's say, you can check that the constraints are passed, and you do this with the command. So you do check the constraints on the specification, and right now it is passing. One constraint that we can modify for you to have an idea what this means is the use of instances. Let's say you have, let's say the seat has some instances, and then the instances are defined with these enumeration values. And one constraint is that, for example, the instances must be defined with an enum. So if you change these and you say, okay, I expect that my dimension is a string, and then you save it, this should complain. Yes, exactly. So you get a reason like this dimension must be an enum. So this is a check. You can pass the validation, but you are not passing the constraints for the modeling guideline. That's why you need both. And these, again, they will be automated in the workflow. What else you can do is you can perform a search. Let's say you want to search for some concept of a door, and then you say, okay, I have a match. I have these two options, have a door count and doors. Those are fields, but maybe you want to also have an extended search or make it case insensitive, which leads you to more, let's say, outcomes. And this says, okay, the door is appearing regardless of the case, naming case, as you see here in multiple places. And you can also have a strict search, which in this case is not giving me result because I don't have any of those cases. I do have, I believe, this, which is appearing. So this is a search function. There is also another function that is available in a different branch that is being reviewed, which is the semantic search. That means you post a sentence or a couple of words about what you're looking for, and then you get some insights into what is there. So that's what the search function is meant for. What else you can do is you can gather statistics of your model. Maybe this is relevant for eventually plotting stuff to say, okay, my domain or my use case, how many entities it has, how many objects in this case, how many control values in the enumerations are listed, and so on. So this is a basic statistical count at the moment, but it can be also further extended to do some other type of analytics. And this is helpful, as I said, for the catalogs mostly, just to say how this model is evolving. And why not having plots around that? What is important for the physical layer, which is in the end where most of the people are working, right? So you need to translate the specification into a different format. If I search for them, exports, there are not too many exporters today, but we can continue to include them. We are also looking for existing tools or scripts that are doing translations so that we are not reinventing from scratch. But for now, we have these three. There is also an idea of having maybe some generic exporter that is basically wrapping around a mapping language that we can basically develop. But this is still something to be discussed. So for the time being, let's show how the JSON schema would look like. So we export this to the, let's say how I call it, exported JSON. This is the one. And you see the specification is now exported in JSON schema. There are some functions here. You can decide whether you want to expand the instances or not, and you can play around with that. Another exporter that is relevant for this round, I believe it's exporting to the VSpec syntax. And for this, I'm selecting just the vehicle because the other domains are using other data types that are not mappable. And it is complaining, but if I just export the vehicle, then I can export the vehicle back. So I have like, let's say, exported vehicle. As you see here, this is also one of the problems of these languages, that you don't have support of the tools out of the box. Luckily, it's based on YAML, and then we can just have some syntax. But the specification is now exported in this VSpec format that can be used, as we showed in the last AMM. This output can be used with existing tools in VSS, so it's compatible. Good. Another thing you can do is you can do the identification, and with the identification of concepts, you can enable the work in the semantic web. So, for example, you can generate, we call it a skeleton. It is an RDF file written in this turtle syntax, turtle serialization format. And then we have an output that is looking like this. This is RDF. So you can configure the namespace. You can call it like whatever organization or like domain you have. You can put it here, and you basically are able to construct automatically these type of structures, and they are used for something more expressive. Let's say if we search for, so we have all these concepts are basically containing future-proof identifiers. So that is the purpose of this. Wherever you see NS, it's just a prefix of the namespace. This can be arbitrarily selected. And this means that, okay, there exists a concept that is called window is open, or window position, window switch. And you can reuse this in order to say something else about this. This is based on unique uniform resource identifiers, and you can also basically create those with this command. Let's move back to the terminal. And then you have a registry. You trigger the concept URI creation, and you create, let me see, this file. For now, they are exported as file for this example, but these are only artifacts that will be used in the workflow that is automated. That is the main purpose. So if we search for, let's say, if I find namespace window or vehicle dot some window. Yeah, we have the concept of a window, like vehicle cabin door window. This was coming from VSS. So this means basically I have a unique ID that is called the window, and it has some fields. So it's just giving you the IDs for these that are reused in order to create these type of structures that you see here. Maybe they are not too readable, but in here you mean we can have a collection. In this case, the angle is written in English. You can have different languages for that. Good. Any questions so far before I move on?
Yes.
Yeah,
That's right.
so I'm curious, again, this is Rajiv from RTI. So one question I have is like the constraint example that you showed. Where did you specify the constraint, right? Where your checker was saying, okay, this dimension, when you change it to string, the check failed. It had to be an enum. Yeah, where is that?
It's in the same specification.
It's
Do you want to go back to the files? So where the constraints are explicitly mentioned for cabin.
The constraints are checked by the tools. And if you remember this slide from the previous slot, basically this is what is being checked by the tools. So this is a constraint that is basically making it mandatory for you. In order to specify instances, you need to have instances with enumerations in order to control what is expected, and so that we have a control vocabulary for the instances and having more structure. So this is a constraint. If you don't use this, it will still be valid, but it will not be according to the guideline that we are proposing. Right. So this is one of the little constraints we have with the with modeling.
at instance tag is how you specify. Is that part of GraphQL or is that something that's an extension?
It's a custom extension.
Which is coming from the S2VM?
Yeah. No, we are defining it in the GraphQL itself.
Okay. So
Yeah,
in
you can.
GraphQL,
It's kind of like a
define
custom annotations.
Yes. Yeah, like they are programmatically accessible. So those are annotations on the schema language.
Basically, yeah.
This,
You don't need to touch tooling there. Basically, you define in the GraphQL itself, and they are accessible.
And then the S2DM tool knows these.
Yep.
Sort of, so all of these ads are constraints based.
Annotations. We can
Annotate,
annotations. Yes. And we want to limit them as much as possible so that we don't have to build custom tooling around the schema of what we define inside those custom annotations.
You have instances that are unbounded, like the example you had was enums, right? So it's n by n, like the two enums, right? It's 2 dimensions, but they're finite dimensions. Can you have unbounded? Like, can you have can you add a third dimension that's just an int, for example?
can you rephrase the question? I didn't see.
It might apply to objects.
You were saying something, Daniel?
If you can rephrase the question, because I didn't hear.
Yeah, so the question is like, can you have enums? Like, I know in that example you use enum, but like, let's say if I want to have an unbounded number of instances, or really not a finite.
Like a dynamic array.
Yeah, like,
kind of thing.
I could have 5, I could have 10, or I could have 50, right? And I don't want to sort of specify, like with an enum, you're listing exactly how many you have in terms of choices. Is that possible? Or?
The goal is to have that control vocabulary and evolve as we
Yeah,
like so the question is, Daniel, is it possible to have like an unlimited or unbounded definition of instances?
Yes, it is possible. So the idea or the vision is that you model the concept in an abstract way without instances. That would be the ideal way of doing that, because
Instances.
the instances are basically useful when you move to the physical layer, because there you will have the actual schema of the database that is expecting a certain set of possibilities. But before that, I would say like it's better to just, in this example, model the door without instance. And then before you trigger the export, you can pass the extension. and you can pass extension for different profiles because, I don't know, SUV might have 2 rows, whereas a convertible sport car might have just 1 row. The same for doors, windows, you name it, right? So those different combinations should be passed in this way, in my opinion. Yeah, but in the end, what you can define as for the instantiation, this is arbitrarily selected by you. So far, we have a common set of I call it instance tags. So these are types that are explaining or distinguishing a particular occurrence of an entity, like the in-cabin area 2x2, which might be reused by the window, by the seat, by the door, for example. But it can be arbitrarily selected by you, right? So it's not, you're not obliged to use this, and you can extend it as much as you want. In the end, the tools, what they do is they parse this, and they compute the combination, and you will have then like these instances unfolded, like front driver seat, front passenger seat, rear driver seat, and rear passenger side. Yes.
Export a different one, right? If you want to go to a 3 row, then you would just have a new
Extension,
type,
new type.
and then for your instances, you would extend it with that. Okay. Understood.
Yep.
Yeah, but I think the key of this, of leveraging this, will be to do this. So you don't provide the instances in your abstract
Yes.
semantic
Abstract
model.
definition. You give that freedom to extend based on
Exactly. You keep the concepts as first as small as possible, so that they are modularly done, and then you can also like cherry pick what you need. You can compose from different places, and once you are there, you can basically indicate which types will have instances, and when they do, what kind of instances. And you can maybe at some point create different profiles for different types of cars or different models of the same car, you know. Good. Can I go back?
Yes, please.
Now this is corrupted somehow. Okay, so where were we? Okay, so I show you what you can more or less do with the tools in the command line interface. These can be, for example, in the future also further abstracted in the form of a graphical interface, and why not by a conversation with the language model. But we want to achieve, we want to get to the point that we have a stable ground to work. And once you have this in place, basically you can use other tools. Let me see if I have them here. Open.
This will be done. This is what everyone wants to see. Why we picked GraphQL.
I have too many windows open here, sorry.
Make sure you share the right one.
Exactly.
No, we don't mind seeing the baby pictures either.
Okay, let's see.
Is there
this
a
here.
long-term goal that you would be able, to the?
Okay, so for
export to that?
We are internally doing the POC to just have an exporter of VDM to grab protobufs.
To that.
Because it's already in-
IP, whatever you're using.
Yes. Internally, we use protobufs, and then we are having a POC to do that.
good. Can you still see my screen?
Yes.
Okay, so just to cover a few examples, there are plenty of tools. I included one slide with some resources, and the slide deck will be distributed afterwards. So feel free to just check it out. But I selected just what I think it's nice to show. There are some editors that let you visually create these models. This in particular, I believe, is not free, but you can still get access to the free version, or you can pay a subscription for that if you want. But basically, you can do something like this in the same way we were working before. So we have the concept of a person, and then you can say, okay, I have a type, I don't know, a driving journey. And then it says like the driver is the person, for example. Then it creates this link for you, and then you can also do it in this way. You can create something as like a car as a concept, and then the car has a driver, and then it has a driver, a person. Yeah. So you see, it's quite easy to follow. But this in particular, I believe, is not free, but I think it's pretty interesting. We also have other options like where is this? This is open source and free. It's called GraphQL Voyager. I have here included the schema that was created in this example. In this case, you have the tree of VSS is available here. But let's go to the, let's say, the charging station. And these are all the concepts we just modeled here. Charging station has a charge point, and then it has a parking type, and then the parking type has also control vocabulary here. So those are all the items we modeled before. I think this is also pretty nice, and you can embed it in any web application. It's pretty nice way of complementing data catalog, for example. There are also other tools that are oriented towards the API itself, but still you can reuse some of the functions they have. For example, GraphQL is a query language, so that you can also post queries on the API, but you can also validate that the query exists in your schema, or what you want to retrieve from the schema is valid. And you have tools that let you like search without auto completion. Let's say this is coming from the schema, and then there is an API behind that is giving you the instance data. But for the moment, it is important to remark that the query functionality, the auto completion mechanism, it's the focus. At some point, if we have an API around GraphQL, would be also nice to see it here, but it's not mandatory, of course. Yeah, so if you want to search more, you can always search for awesome GraphQL. There are some options. So you see like plenty of links. You can play around to see what is something that can be beneficial for you. That is when it comes to GraphQL. And then we have also for the RDF, if I go back to the example, this is the example. This is not the one we want. This is the one I wanted. Yeah. So in this example, you may remember that we created this skeleton, and in the RDF ecosystem, you also have tools that let you do something like editing the vocabulary. Yeah, for some reason I don't remember the credentials for my Workbench instance, but this is an open source project from a company that does a lot of work on semantics, or like it was also initiative from the European Union. You can edit the vocabularies there. You can create something like this. Let me see where this is. Good. So with those editors, you can basically enhance the RDF. In this example, I took the idea of classifying the window with multiple hierarchies. One hierarchy is by physical membership. So in the end, this is nothing more than the triples, as I explained before. So this means vehicle is a concept and it has a preferred label, and the window is a concept, it has a preferred label. And then you can start classifying these by saying the window has a broader concept door, or it is occurring in the scheme vehicle physical membership. So you don't need to do this manually. You can if you know what you're doing, but there are tools around this that let you construct this. They are more or less open source in some cases, like Protege or this Workbench, and you can construct this. What you can do with this, you can also go to other tool like Scosplay. You can load this file, and then in this example, you have 4 different hierarchical classification. And let's say by physical membership, you can, sorry, I need to refresh this, I guess. So once you select this, let's say you go physical membership, I believe this was the example shown in the first session. And you have, let's say, the cabin, door, and then the window. This is similar to what BSS is doing, but you can enhance this with arbitrary hierarchies by saying this is the window is a unidimensional movable part, and it appears here. So this is not compromising the schema that you where you express what a window is and what the output data type is, but this is letting you to do more on top when it comes to just classifications and then multiple labels for the concepts themselves. So again, you have this Workbench, you have also Protege. This is an open source editor for those. There is also Web Protege. I don't have access to this resource at the moment because of the VPN, I guess, but feel free to check it out. And yeah, because of time, I suggest that we move forward to the last part.
Yep. Thanks, Daniel. Yeah.
Okay, so last part is...
Yep. So Dan, there's a question. Yeah.
Yeah, in terms of leveraging existing tooling, has anybody looked at using Eclipse EMF to extend the export capabilities here? Because there's a whole lot of stuff there that we can use, and there's an input for GraphQML already.
Not that I'm aware of. Are you aware of Eclipse EMF?
What was the question?
Eclipse EMF.
No, I'm not familiar with that.
No.
You should look into that because that provides a lot of the same things, and you can import export between the 2 modeling types. And,
2 modeling types of existing.
Yeah.
Yep. We'll take a look into that too. Yeah. So ultimate goal is to, instead of reinventing the wheel, just use what's accepted by the community outside of automotive too, so that we can leverage all the toolings and workflows available as open source. So
Good.
yep, we'll take a look, definitely.
Okay, so if I can, let me just show you some other aspects that are possible and we have been working on. The principle of reusing existing standards. This is something that many times is overlooked, but in my opinion is one of the fundamental principles of any data modeling activities is reusing what is there. And a clear example where this can be beneficial is the area of units and quantity kinds. If you are familiar with the BSS project, there we have a units file that is containing I don't know how many, 20 or 30 units, or maybe around 50 or no, but I believe no more. But in practice or in the real world, we have hundreds of them. And there is a model that is called the QUDT, which stands for quantities, units, dimensions, and data types. It contains a pretty comprehensive set of units, for example. And we have a mechanism in the tools that is basically syncing from this model, which is exposed as RDF actually, but we are importing that into the GraphQL schemas in order to be compatible. And it looks like this. So we have a quantity kind temperature that contains some compatible units, and these are the unit labels, like degrees in Celsius, degrees in Fahrenheit. And importantly to note is that we are annotating that provenance with a custom directive saying, okay, this came from this place. So we are not reinventing that. We are using an existing model, and by knowing this, what you can do is this model also offers conversion formulas, so you can compute different compatible units and then just do the translation on, in the implementation, right? So this is a very important point. Another aspect that we are dealing with is being able to compose the model in the way you want in order to trigger the tools tailored to certain use cases in which you don't need to have the full specification. One clear example is people that work with protobuf. Protobuf in the end is about messages, and if you are giving some team that works with protobuf a set of concepts in your model, it is very likely that these people will not be wanting to have one message per concept that you offer them. Maybe they group the concepts in different set of messages, and it is important to be able to first compose from different places, like from different sources. Then once this is composed, you post a query, you sub-select what you want, and then you create a prompt version of the schema. And with this sub-selection, you basically trigger the tools and you create the export you want. I can show you something that was basically showing the value of this. I did a small proof of concept in which you can provide your specification in GraphQL, and then you have the selection query with this query mechanism that I show you from the tools that are supported. And then the tools that we have in COVESA basically can do this sub-selection for you and trigger some export. In this case, I want to create a protobuf message. The example is as follows. You have this reference model that contains different entities, and I want to select just the location for the vehicle, for the person, and also for the charging station. So the idea is that you post the query. This is a valid query that you have here because all the elements that are listed here are existing in the reference schema that you see at the top. Whereas if you try to select something that is not existing, the tools will complain that says, okay, this field is wrong or this doesn't exist. And once you have this selection, you can apply the exporting logic and then obtain something like this. In this example, you have, let's say, hierarchical messages that are telling you, okay, this is the location for each of the elements that you selected. Or alternatively, you could potentially also configure the tools to say, I want a flat message that contains just the items I wanted. And then maybe here, this can be complemented with some provenance annotation that says, okay, this vehicle location came from this concept in my reference model.
Yes, there's a question. Yeah.
Just real quick, you mentioned doing a query to pull out data. I assume you can do something similar for an update, like if you want to move the window up.
Yes.
So here every example I'm showing here is example on the metadata, because this is in principle at first stage is not based on the API that you will serve the instance data. But of course, if you decide to have an API that is
with the data
directly from the schema, then it will be about modifying the actual value of the properties you have defined. But in here, I am using the query mechanism as a way just to selecting the concepts from my model and just doing something.
So kind of related to that. So the GraphQL query language is really just being used for the metadata, right? It's not being used for real data. That's, I think, an important.
That's a confusion. Yes,
I
yes.
think wasn't very clear in the beginning coming in, but I think that's nice.
We are leveraging only the definition language and then using the whole ecosystem in our world.
Yeah.
But if you want, you can establish in your own workflow, like, yes, I have everything defined here. I want to establish APIs to database access.
Not kind of force you to have a GraphQL server in your vehicle.
Exactly.
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 I think that's an important distinction that that's easy to miss. I think for people who might have just read up on GraphQL.
Like every time if you search.
I miss that too.
That's important. For modeling language is independent of what actually goes in the car, because otherwise you can't manage the concepts.
Concepts.
Right. No, it's a great point. We just have to keep reiterating it.
Yes, yes.
Everybody gets it.
Yeah. Well, kind of related to Daniel's example, right? You've got the flattened versus hierarchical pro-buff structure, right? So was a different query for the flattened one, or because again, there are many ways to do it. Is that
it's a different
query.
You can also
is that flattened thing coming from the graph QL query on the metadata.
Tools can be extended to generate both.
Okay. I mean, you can do the query, build the sort of the
hierarchical model
for a structure, and then flatten it out. But so that's one approach, right? That's a post-processing tool. But a different approach would be you query the graph, use a GraphQL query, but now the query sort of is formulated in a way that it creates a flattened structure. And I'm just trying to understand what approach you've used here in this example.
Dan, you want to take that?
What was the question in the end?
Because the question is like we have two different things, right? So I can query as a hierarchical and then flatten it using post-processing tools, or I can just flatten it directly as a part of.
Yeah. So in the example I just proved the concept so that it works. In the end, I believe that the tools should give you the possibility to configure the output in the way you need, because the downstream use might differ a lot. From even within the same company, you might have different teams that need different shapes or different structures. So there is no, let's say, one size fits all. That's what I see. But in some cases, you might decide to have the flattest structure. In other cases, you might need the hierarchy. That's why I think it's also important to mention that these kind of configurations are something that where the tools can help.
Yep. Go ahead. One more.
So some of the things that we may have to represent is something like ownership, that who owns the data, produces the data, or things like, it needs to be synchronized, like, not all data needs to be synchronized to the vehicle to the cloud, only a subset of them is synchronized. Or things like, if there are multiple entities which can change the data, how do you actually represent that?
So
Is
you-
that something easily extendable in this?
You mean to say like providing annotations for data collection platform? Like
Say,
classifying the data for data collection platform, basically what you need to collect, what's by use case and all this. That's more of like annotations that goes how you classify the data, right?
and that is something that's global, so is there a separate schema to it?
That can be doable by using custom directives and annotations. So as we go moving forward with, okay, so let's support the basic directives that we want, and then we can extend it based on the what we want to see in the schema. So typically, how the data is used might change from use case to use case, and it's hard to get a common alignment from different organizations. So our goal is to let's align on the concepts, let's align on the schema first, then we can have a separate data set or the configuration on top of it, where you can apply to the base schema and generate respective artifacts.
Okay. Because of time, let us just cover the last slide.
Oh, yeah.
and
Yes,
then and then we can maybe wrap it up. Yeah, so the roadmap was already covered in the first session, but I think it's important to visit it again. Again, we have like two work streams within the same project. One is the modeling approach, which has some features or challenges. And the second one is the model itself, the domain model itself that comes from applying this method systematically. Now, COVESA is today not having a fixed scope for this because, as mentioned, there are more possibilities to express subdomains like we covered today, the charging session, just as an example. But the idea would be for COVESA to identify what is relevant to have, what is relevant to standardize, and where other organizations can contribute and commit. And we are quite open in that sense in both repositories. Any contribution is welcome, and we are happy to just have you contributing in these initiatives. So this is a rough plan. It's not written on stone, so we can further steer that if needed. But roughly speaking, I think those are the main milestones that we want to achieve. Yeah, and you are invited kindly to attend weekly meetings on this topic, and also to post your questions or suggestions directly in the repositories, and we will address the questions there either in the discussions or the issues. So you are kindly invited to do so.
Yep.
So you may have a look at the resources link I provided here, and with that, basically I conclude the content I wanted to share with you today. I hope you had a better understanding of what this initiative means, what we are aiming for. And I'm happy to address maybe a couple more questions if there is. Otherwise, we can wrap it up.
One last thing, a big shout out to Daniel and his team. Without their extended effort, we'll not be in a situation where we are today to present it. Thanks, Dan.
Yeah, thank you, guys.
Any further question? I know we are already out of time, but feel free to reach out to us directly on COVESA accounts, or the meeting invites are already there. If you want to hop in, just hop in and, just work with us. Yeah. Thank you.
Okay, thank you so much.
Thanks,
Have
everyone. Thanks,
a
Dan.
day and enjoy the event.